So hopefully you can see my slide and you can hear me and also see me. Right? See my slide?
Yes, yeah, I
Okay,
can see
awesome.
the
Yeah.
slide. Thanks.
Perfect. Okay, so welcome to the 53 meetup. Today is August 15, Tuesday. So we have a very busy agenda for the next hour. Lots of interesting stuff to cover. We'll start with the greeting. If you are new to the meetup, we are meeting once a month to share ideas about C++ and uh, basically learn. That's the goal. Learn new things and use it in our daily uh, working experience. And uh, sometimes I'll bring other people to present. Sometimes it will be me. Uh, so we have lots of interesting topics in the past and upcoming ones in the future. By all means, if you would like to present anything from a full topic to half a topic or a lightning talk, just let me know. I can help you with that. This is sponsored by Qualcomm Wireless Software Group. Thank you, Charles Bergen, for sponsoring the meetup fee. We have a Dropbox link for all the sessions material. We do have a YouTube channel uh, where we upload all the recording. So everything is recorded. There's few dozens of already existing recording on the YouTube channel. Just Google SDCPP MU, which is San Diego C Meetup. Discord asked me for a link. It keeps expiring, and people ask me for the link to the meetup page, and I'm just basically share that with them. And then we can once you admit it to the server, you can do whatever you want and like ask questions and participate in the Discord channel. Um, you can contact me through like two options. One is the Kobe_CA handle, which is written here. The other one is the SDCPP meetup, which I'm managing this handle on Twitter. Just Twitter. I don't have anything else, not any other account. Um, this is Martin's blog post, which blog site, which I have a page there with all my posts, like previous posts. So feel free to browse it. Uh, next month we have JFrog lining up for September 12th, 5 p.m. Pacific time. We would discuss Conan 2.0. So we had at least a couple of sessions by JFrog in the past couple of years, maybe 2-3 years, discussing Conan 1.x, and the upcoming one would be 2.0. What's new? How to use it in C++ and CMake. Super interesting. I'm looking forward for this session. If you are from Qualcomm, it's going to be announced this week. I haven't announced it yet, so this is why you might not be familiar with that yet. Okay, so from that point, we'll start talking about the actual agenda. We'll start with a recent book that was published. It's basically a third edition of an existing small reference book, which is regarding range v3. I have only great things to say about this book. Like if you using C++ and range v3, even if you're not using range v3, you're using the standard ranges, it's gonna be very helpful because there's some things that are very similar and overlap. But if you're using range v3 library, this is an amazing book, both on the content and the way it's being written. So you have two options. One is already PDF and the print, or just the PDF. It's worth every penny. It is shipped from Europe, I think Switzerland, if I'm not mistaken. Worth every penny, believe me. It's such a fun book, and the website has one example that we can go over just for fun, just to show you how ranges is such a fun thing to kind of write with. So FizzBuzz. So FizzBuzz is kind of a test that I don't know if people say it's an interview test, but it's basically a fun exercise because there's so many ways to do that. By the way, LeanPub has a book about FizzBuzz, about all kinds of various ways to kind of write FizzBuzz solutions. So the idea is really simple. You need to generate a sequence with fizz if the number is divisible by 3, buzz if it's by 5, and then FizzBuzz if it's both 3 and 5. Otherwise, you just print the number itself. So there are multiple ways to do that, believe me. This is just one fun way. So here's how it's being done in this example. Again, this is taken from the website. We have an array of 3 and an array of 5, just an array of std string. 3 has empty, and fizz, and buzz has the first fourth empty and then buzz. And then we start building we start creating the small building blocks to create the solution itself. So first of all, you create a lazy range that takes fizz and buzz and just cycle through. So view is called cycle, which just like as long as you consume the range, like iterate through the range, you'll get the empty fizz, empty fizz, and so on and so forth. And similar with cycle doing on buzz, it's just 4 empty and then buzz, and then 4 empty and buzz. So we have that cycle. So that's one thing. And then we can do zip width, and we can plus the 2 strings. So plusing 2 strings would be if I have a fizz and a buzz would be the same. If I have just fizz with an empty, it would be fizz. Empty with buzz would be buzz. So we're taking these two infinite kind of ranges, lazy evaluated ranges, and we create another lazy range. Nothing is computed yet. We're just building the small elements, right? So if we iterate through that, we'll have empty fizz, empty buzz, because empty plus buzz would be buzz, and then fizz. And then if they are aligning, 3 and 5 align, you'll have fizz buzz. Okay, so we almost done. The last thing that left for us to do is to fill the empty with the actual numbers. So iota is what you usually reaching for if you need this infinite stream of values. So we have iota, and we want to transform that with this function. So the idea is that to take the number and make it a string, because we are dealing with strings. So that's the whole idea. So now we have this lazy evaluated range on 1, 2, 3, 4, 5, and so on and so forth. But they are strings. They're not integers because we did transform. Okay, and the last one is basically taking this one, this range, and this range, and again zip them together, having max. So max basically, if you have an empty string and you have non-empty string, you'll get the non-empty string, which would be the number. So this is where we have the final solution, zipping 2 with max, 1, 2, and then fizz because fizz was here, and then 4 because 4 was empty here, buzz because buzz was here, and so on and so forth. And fizz buzz would be the same here. So this is a very fun approach to implement this this question. I found it very fun, and the idea behind it is really there's a lot of exercise in the book. It's ordered very nicely, starting from the simple building blocks of ranges all the way to the more complex one. There's a lot of exercise like this, so you have 1 or 2 pages of a specific problem and the solution. Super fun. So yeah, go for it. CPP quiz. So going back to the agenda, I just want to make sure that, so we have one small, so after the CPP quiz, which would have only one today, so we can make sure that we have time for everything. We'll talk about trivial and standard layout after the quiz, and then the main thing would be, half an hour would be Mutex and synchronization mechanism in class. some discussion about how to do things in a kind of a more maintainable way. And then Will Hawkins, which I don't know, Will, are you on the bridge already or not yet? So I don't know if Will is here yet, but we have Will Hawkins for the lightning talk. Just want to make sure that no one is actually contact me. Okay, so actually Will is trying to access the Zoom. Okay, so let me just give me a sec. Okay, hopefully can join. Okay, so let's have just one fun CPP quiz, the 354, which is this one, and I'll switch to the web interface so we can actually try it out. Okay, so this is the question. It's actually a new question in CPP quiz that I really liked. So take a look and think about the answer. You can shout the answer, by the way. What do you think? So we have this struct with just in the destructor, we're just printing the character and reconstruct it here and here. Just so there's a global one, and this is just on the stack of main, and we call exit. So what happened? And now, in the meantime, I'm going to switch to the other one. It didn't work. 1 second. Okay. What do you think?
Only B.
B. Why?
Yeah, I guess just
The destructor
B.
of S gets calls in the when you exit the scope of main with exit, I assume. But
Yeah. So there is a specific rule with exit. So the question is, okay. So the question is would exit trigger destructors of both S in A or B? Is it going to be A only, B only, both of them, or none? So, it's not going to compile. Let's assume it's going to compile, and it is defined by the standard, and it's all implementation specific.
I would guess B, because I don't think exit calls the destructor of non-local
B.
variables.
I guess it will be B and A because exit 0 is a valid exit, I guess.
Okay, so it's not B, it's not B and A, so we have A only left. Obviously, there is something. So it's A. The reason is that exit doesn't call the destructor of object of like automatic, what we call automatic one, like stack. It's going to call destructors of the static storage, which is this one. So that's a very important, because in some cases we tend to have calling stud exit, and the implication is that it's not going to, if you care about the destructor of your non-static storage duration ones, you lose the destructors. It's not gonna happen. So just FYI, that's what happened here. Okay, so let's continue. I like this new feature of Teams where you can actually go to the task manager and say, okay, I want to share this window. Okay. trivial and standard layout. So this is actually was triggered from a tweet that happened was 3 months ago, not 2 months ago, a couple months ago. And so I prepared that about a month and a half back, the slides. I would like to kind of call out the talk that happened on CPPCon 2022 from Nina. I attended this talk. It's a great talk about the type categories. It's super important. It's not like a theoretical kind of a talk, but it's a great talk about understanding type, and we'll touch about a couple of them today. But it's important to understand why they exist and what you can do with each. Okay, so what triggered that? Eric Nibbler was asking, is this a standard layout? And I was hoping that it is standard layout because it looks pretty benign, but I wasn't sure. I would pick standard layout. So Peter Dimov, which is very known persona in the C++ community, had a bonus quiz. Does this work? Which is B deconstructed to I and J. So basically, if you think about the layout, there is an I and J, then you deconstruct it to the I and J's. Okay, so this could be X and Y, where I and J are deconstructed to X and Y. So there were all kinds of people saying, okay, it's a standard. This is a joke. It's standard because it defined it as standard. This is a joke, obviously. People were expecting it to be standard layout because it looks pretty benign. Can you do B? Can you initialize B with just X, comma Y, or do you need to have B initialized with curly braces around the first one, which is X, and then comma Y? So we'll see all of that. Anyway, lots of people were assuming standard layout. I haven't checked the tweet recently, like what happened beyond June 2nd, but that's basically just a snapshot of June 2nd. Okay, so let's start discussing that, like what exactly this actually means. Okay, so here's the compiler explorer. It's not a standard layout. It's a trivial one, but it's not a standard layout. So we'll talk about what does it mean trivial and what does it mean in standard layout. This doesn't work. So the person that actually was Peter Dimov that was asking about that, this doesn't work. If you uncomment this line, you'll get this. Cannot decompose class B, but it's his base class, no static data members. So it cannot be decomposed. Okay, so that's one thing. So we have an answer for that. Next, can we do this? No, we can't. So we cannot initialize B by having 1 and comma 2 or X comma Y. We need to say, okay, this is A, like have the X kind of curly braces, comma 2. Now we get into the next 4 or 5 slides talking about trivial versus standard. Let's start with trivial. Before we jump into standard, because this is a trivial class, B is a trivial class, so we talk about trivial. First, what is the usage of that? And I'm just going to dump the kind of the definition, and we'll talk about it together. Okay, so what is a trivial layout? So there are all kinds of what is qualified as a trivial layout. So let's read it together. Compiler provided or explicitly defaulted special member functions. So special member functions, talking about copy, move, all of that, either compiler provided or explicitly defaulted. Then it's a trivial type. It occupies a contiguous memory area, which is important if you need to interact with other languages like C. It can have members with different access specifiers. So you can have private and public different access specifiers. You cannot reliably consume them from C programs. So you can interact, but not reliably. We'll see how that can be improved. Okay, so a trivial type T can be copied into an array. That's basically what I said. It's kind of a C-ish kind of a interface. It can be copied into an array of characters or unsigned and simply copied back. So you can copy T into character array and back. This is safe. This is defined. You might have padding between type members, which we all know. Okay, so that's FYI. Trivial types, they have trivial default constructor, copy assignment, and trivial destructor. What does it mean? It means the constructor operators, destructor, they are not user provided. The class doesn't have virtual functions or virtual base classes, which obviously trivial would not have that. No base classes with non-trivial. So if you have a base class with non-trivial constructor, like a constructor user defined, that whole, like the derived one, because it's a base class, the derived one is not trivial anymore. No data members of class type with corresponding non. So the members themselves, they need to be trivial as well. So otherwise, like this is playing very nicely with other rules in C++, that if you have a class, in order for the class to be qualified to a specific type, the members should be same type, or that there can be something which is more than what we have. Think about if you have a class that has a unique pointer. This class is a member. This class by itself is now not copyable anymore because it has a member that is not copyable. So all of that is playing very nicely. So you don't really need to remember much about the members. The members should be playing should be kind of aligned to what the class itself. So let's take a look at an example. So we have two trivial. Trivial two. So if I had only this constructor that you can see that I'm highlighting, that's not a trivial. I actually needed to, not I, but this is actually coming from, by the way, I should mention that there's a nice, from the Microsoft Learn blog post, there is a very nice blog post about this specific domain. So feel free to look at it. If just search for that on the web. So I need to add equal default. I need to default the default constructor for the type to be trivial. Take a look. I can have different access specifiers. That's fine. So I can copy that to a character array, copy that back. Fine. Since they are different access specifiers, not reliably interacting with C in terms of the API. Okay, so trivial. Let's talk about standard layout. Standard layout is something simple, doesn't contain C++ features like virtual functions, which are not part of C. This is basically perfect. Standard layout would be perfect thing to interact with C. Can be consumed by C program. All the members, they have the same access control. So that's more strict than what we have in the trivial, because there's only one, whatever you pick, but only one access control. So then it's a standard layout. Again, it's mem copyable back and forth from character array. That's probably already known, because it's kind of more strict than the trivial. Can be consumed by C programs, API stable, standard layout. They have user defined. They can have user defined special members. Standard like it has this characteristics. No virtual function, because we said no C++ features. No virtual base classes, obviously. Same access control, all the data members. All non-static members, they also have the standard. So same deal. The members, they also need to be standard layout in order for the class or structure that contain the members to be a standard layout. Base class should be standard layout. So it has no base class of the same type as the first non-static data member. So the first non-static data member, you cannot have a base class with the same type. So that's a restriction. One of these conditions it needs to meet. Yeah, no base class with non-static data members. And no non-static data members in the most derived class, and no more than one base class with non-static data member. So either one. Okay, so let's take a look at some examples. This is a standard layout. So it's all the members, they have same access. User-defined constructor is okay. Okay, but it's not trivial because we needed to default it. Kind of funny. I would expect that would be different, but that's fine. This base is standard layout. This is also standard. Standard layout of derived is false. This base is okay, and the reason for that, I forget. I need to look again. But the base here, the base is fine. The standard layout is fine. So, okay. The reason is that we have INJ. They are non-static data members. The base has with non-static data members. So, that actually the reason for that. It has non-static data members. So that's a problem. Okay, so when a class is both trivial and standard layout, this is the pod. So we used to, before we had these categories, we used to talk only on pod, which is plain old data. So the memory of a pod is contiguous. Each member has the higher address than the member that is declared before it. So that byte by byte copy with kind of binary IO can be performed with these types, all good. Scalar types like integer and others are pod types by definition. Yeah, pod types that are classes can only have pod types as non-static data members. Object, so we're talking about non-static data members which are part of the object. And this is kind of a summary. This is inheriting from B. It has a virtual. It's not trivial and not standard. Okay. C is trivial, but non-standard. We have a different access specifiers. Okay, different access control. This is standard layout, but not trivial because the user-defined constructor. If I just write equal default, that's different. It's going to be trivial. But it is a standard layout. It's everything looks fine. You allowed in standard layout to have this kind of constructor. This is a pod. Like the simplest thing, A and B, nothing special. Okay. So that was related to trivial versus standard. There are, again, I just want to make sure that if you have a chance to look at Nina's talk, it's great. The talk is 53 minutes, but I think it's like 45 plus the rest is kind of Q&As. It's a great talk, and you understand how much, like how many like subtleties there are in the language. But it's important at least to understand. At least the idea behind that is when you need to interact with, you need to understand that can you copy back and forth from character array? Can you interact with C? Then you have, at least to go into a CPP reference and take a look at your class, or maybe use type traits. By the way, there's a lot of type traits to help you if it's trivial or standard and similar. So let's see if there is yeah, so both, for example, is trivial and standard. So at least you know what to do and where to go in order to verify that your type can actually meet what you want. Okay. So the next item talks about concurrency, mutex, synchronization, and similar in class. And it's kind of inspired by code that I'm seeing all over the place in all kinds of areas on the internet and similar. Okay, the disclaimer is that the domain is huge. We'll talk about very specific use cases. So we're not talking about message queues like typing concurrency, not talking about coroutines, anything else. There's so many things that we can discuss in this context, but it's just I picked something which is very specific and super interesting. Okay, let's start. So imagine the following production code. So you have a class foo. You have public function using the members, read, write, mutex here, mutex there. So we have this standard mutex, bar mutex, which is just looking at the name, it's probably related to bar. There is a count mutex that might relate to count, might relate to average. Mutable or not mutable mutex doesn't really matter, but probably bar is related to bar, count related to average, and I don't know about count. So I don't. When I read that, I have questions about how the implementation would look like. So what are the issues in this code? Like think about it for a second. We have cohesion issues. Like it's not there might be bar might be correlated to bar mutex might be correlated to bar. That there's a strong cohesion between these two, but maybe a very low or weak cohesion with the other ones. I don't know. It's really hard because there might be more mutex elements and more variables that related, and it can be the mutex might be targeting one more data members, maybe containers. It can be std string, it could be vector, it could be anything, and everyone is touching it. And what happens if you need combination of these two? Is it easy to reason about the code? Are you worried about deadlocks? When you look at the code and you look at multiple lines, blocking multiple mutex in order to make sure that there is no race condition on accessing the data members that you aimed, that the mutex is aiming to protect, can you reason about it? Can you make sure that there are no deadlocks? Will you actually remember to use the right locks? Like there is nothing preventing me from taking bar and using it. No, like there is no enforcement, not in the code. Even tools is going to be super hard, because how do you tell the tools that bar needs to be used only when you holding a mutex of bar mutex? Like it's very hard. Fortunately, at least the naming somehow makes sense. Count mutex, probably count. Bar is probably bar, but no more than that. What do we do with the new requirements on the class? Do we add more members? Do we add more logs? Do you make it more and more complicated and harder to reason about? When do you stop and refactor? How do you make all of that? Do you recognize such pattern? Maybe I should stop for a second. And is this your life sometimes in code that you maintain, or code that you're looking at? It can be anywhere from pet project to anything. Do you have something like that, or maybe you had that in the past? Anything like anyone can think about something that, because I in my career I've seen that multiple times, so it's very common.
It is a common thing. I see it in the code base I'm working with as well.
It's really
So,
common.
Yeah, it's very common.
It's very common. Yeah, I've seen it like endless times. Okay, so long time back, I read a book, pretty much read it cover to cover. It's not an easy book to read in terms of it's hard and advanced. It's about C++ 17. Was published by Arthur Dwyer, and it talks about from 11 all the way to 17, and was published. It says here September 2017 by Packet. The content is really interesting. There is a chapter. There are multiple chapters in all kinds of areas, from file system concurrency and similar. It's a lot of things there. It's kind of a medium to thick book. There is a concurrency chapter. There is a subsection which says always associate a mutex with its controller data. The idea is pretty simple. You have this issue where the mutex or the concurrency locks are scattered, and the data members are also scattered. What if you can associate both of them and provide a syntax and semantic that it's really hard to use it, like to misuse it. It's really easy to use it, really hard, and you eliminate most of the issues that we described in the previous slide. So let's see how we can do that. We'll start with find the bug. This is taken from the book. So you have A, B, C, and D. Take a moment. It's not easy. Concurrency issues are not easy. So let's think about it. There is a mutex and 3 members, sum, count, and average. We're taking a mutex. This is a logguard used in 2 functions. We're taking the mutex. Logguard will release it. This is RAII. Using ctag, we don't specify the mutex type. Logguard is a template class. So here we protect sum and count. Okay. Here we protect the last average by accessing. So last average is also a member. Sum and count, and we return last average. Here we just return last average. The author didn't think that anything needs to be locked.
That's the data range.
Okay. Okay, can you explain?
And we can go back to the definition of data race. So you have 2 accesses from multiple threads. And if one of the accesses is a write, and if one or more, well, if the variable is not, if the access is non-atomic, then that's a data race.
Yeah. So there are actually, there's at least one that the author was pointing, and it was pointing about A and D, which is exactly what you said. Think about M count plus 1 that is protected by the logguard. But I'm actually accessing it here. Think about 2 threads. One is reading and one is modifying at the same time, because I just so there's a think about producer and consumer. However, this is similar because I'm writing it here, right? I'm writing something here. Though it says consumer, but think about producer. Like these 3 are consumers, so they're not thinking about there's a single consumer thread. But if this was a producer one, and this is a consumer, we'll end up with A and D, just like B and C. So it's really like this is a condensed example that I ask you to find the bug, but think about code that you're usually dealing with hundreds of lines, maybe 2,000-3,000 sometimes lines of code that's life, right? That's what we're dealing with. Most of us in many companies are dealing with that, without exceptions. So what do we do? It's hard. Okay, moving forward, let's talk about the idea. Always associate the mutex with its controller data. Again, we'll see the pros and cons. It's not going to completely protect us from all issues, but it would give us some guarantee on the bulk of that. So we'll talk about it in a second. Okay, so locking mutex is required when touching some count, but it's not when required last average. Okay, again, why? Because the way it's being done. So think about this. These are consumers, always single consumer and a single producer. So that's basically the architecture, the threading architecture and threading topology. This is so sum is being count is being touched here, also sum, by the way, and in the producer and also in the consumer. Last average is only last average is here by the consumer, and here also by a consumer, so we good. So one thing that is being noted here, that having more complicated code is violating solid with the S in this SRP, the single responsibility principle. That's FYI, that's always true. So this is kind of an evolution of that. I'll say, okay, I need to guard this one, have some encoded guarded by this, and then so this is kind of an evolution, hoping that the programmer is like associating this sum and count with the mutex, not with the last average. So making a bit more sense, but it's not enough. This is evolution. So let's take a look at the final solution that is described in the book. And if you're coming from other languages, we'll talk about other languages. It's similar. So the idea is the following. We have a guarded class which is templatized on data. So data would be a data member, and we have a mutex. Okay, and we in this class, forget about the handle for example. We have a lock function that returns a handle. Okay, and the idea is once you do dot lock, you get a handle, and from the handle, now you're locked. Only then you can actually use the data. So again, I'm giving you a construct where you wrap your data in a guarded class. Okay, and when you want to use the data, you must go through the dot lock function. You'll get a handle, and from the handle you have access to the data only from the handle. But once you have access to the handle, it's already locked. So how does it work? When you have the handle created, it's basically it's this class, in this internal class, and how it's working. The way it works is the handle is having the lock moved from here, and the reason we're using unique lock is because we need to move it. Okay, so because it needs to be movable, and the data. So the data is here now. It's a pointer here. Now you're holding an instance of this handle, and the lock already is done. So the lock is being taken. Now when you do arrow, you'll get an access to the pointer, and then you can use it. So that's the whole idea. Let's take a look how we can use it. And by the way, this is all RAII. So basically, when you when the handle dies, and the guarded is no, the handle is the important part, because when you have the handle in the scope, it dies, and the unique lock is releasing it. The guarded can be still be in as a member. So let's take a look how we can use it. So same class. This is the guts. We'll call this is basically the data that we want to protect. We put it inside guarded. Okay, last average we don't need because it's from the consumer, so it's not a problem. Now we have this get current average, which was this one. So we have the guarded. In order to access the data inside, we must log it. So pay attention that I have no way to access the data unless I'm doing .log. I have a handle. The handle has an overloaded arrow operator to access whatever we have inside the data, which is sum and count. Okay, so, and this is, by the way, was also noted. This pattern is included in Facebook Foley library under this name, Foley synchronized T, and in another libguarded of Baba getters. That's another instance. So it's impossible for any member function inside streaming average, which m_sc is a member of that, to access the sum and count without that. We cannot use logout. We need to use unique log, as I mentioned, because I need to pass not me, but the pattern is passing this log around and returning it from function. We need to move it. It needs something that is movable. Unique log, usually you want unique log if you need to have that unlog, you need it movable. Then otherwise you use logout, which is much simpler RAII log. Okay, pitfalls. Take a look at that. So we solved the simple, I forget to log the mutex to access the data. But what about this one? Can you hear me?
Yes, we can.
Oh, okay.
It actually logs twice instead of once, probably.
It's logging it twice. But what about the gap between locking here
and there? Yeah, that's a bigger
and get
issue.
count? Yeah, that's an issue. We might compute the incorrect average.
True.
So what happens if I want to fix it and I'm gonna have a unique lock on top of this line? What happened? I'm locking and then get sum is locking and get count is locking. If I'm not using the right mutex, which is recursive mutex, I'm gonna have a deadlock. So yeah, you can fix it by doing that, but you need a recursive mutex. You probably see that because I'm locking it here, and then get sum would lock it here, and if it's not recursive, it would fail. And the general rule with mutex is if you're trying to lock something that is already locked, you block and you wait for the other one. But I'm the one that's actually locking. I'm holding that the same thread is holding the lock, so it's never going to happen. This is I'm deadlocking on myself. So that's basically this is basically the pattern. This is the solution if this is needed, a recursive mutex is needed. We'll have a small detour before we conclude the whole thing. in how do other languages deal with it. So I'm gonna be super fast on Rust. Rust is a very so when I was actually reading when I was reading about Rust, this idea of Rust, where basically the accessing. So I'm just gonna have it very quick. This not data mutex clone is the clone of data mutex. In order to access the data, you need to have lock. Okay, so it's actually this atomic ref count. I'm wrapping it with the mutex and the data. So the way I see it, it's very similar pattern because in order to access the data, I need to lock it first. So that's a very clever idea. When I was looking at Rust a few years ago, this is actually from the book, if I'm not mistaken. This is it gave me the idea that this is very similar to what I've seen a few years back in this in Arthur's book. Okay, so in the rest in the remaining 10 minutes, Will, are you here? Okay, so worst case, if Will is not here, we'll have the lightning talk next time. So in the next 10 minutes, I would like just to highlight another related pattern that helps with thread safe interfaces, because this is basically a problem with thread safe interfaces. Like, how do we do that? So this is one approach to access the data, but I wanted to highlight another approach. And this approach is highlighted in POSA 2. This is a book that I was reading around 2000. I read it kind of cover to cover. It was one of the first books that I was reading regarding pattern softwares, like patterns, but it has a lot of communication oriented material. But it's a great book, by the way, if you have a chance to. Still relevant in C++ code, by the way, not modern C++, because take a look at the year. It's September 2000 was the publication year, but still a very good one. Okay, so what's the idea behind? So chapter 4 has the thread safe interface. So what's the idea behind thread safe interface? Thread safe interface talks about a class that has an API, a public API, and in order to access resources of this class, you need to have locks from whatever reasons. How do you minimize the locks? How do you make sure that you don't have deadlocks? How do you make it easier to maintain? So this all the questions, same questions that we had before, but kind of more into targeting into the interface. Do we need recursive lock? How do we use recursive lock in case it is needed? So the idea is when you design the thread safe components, your class, which is thread safe, and there is example of file cache that we'll see in the next few examples. You want to make sure that you minimize locking and you don't want to have deadlock. Okay, so here's one implementation. Okay, so we have file cache that is has a template parameter of lock. So this is a very common theme in the book, having policies or strategies that are defined as template parameters. So I basically can have file cache with template parameter of lock that is a null op, which is sometimes maybe I have a use case where I don't need to use lock, so I want to have, so I can instantiate file cache with no lock. It's a great way to kind of have a very flexible by having such policies in the class template. So now if I have null, no op, lock, all good, right? There is no issue with that because there is no synchronization issue here because let's say I'm single threaded, but what if I need locks? What if in the insert function, when I'm taking a lock, I'm also calling lookup? Would I self deadlock? It depends. If I have a regular mutex, non-recursive one, I might be self deadlocking. So it's an issue. So how do we fix that? So the book has. So let's talk about the requirements before the solutions. You want to avoid self deadlocks. You want to reach out to non-recursive lock as much as possible, because recursive lock are more expensive. You should try to avoid them. So you need to carefully design it. One method requiring a lock calls another method to require the lock would require a recursive mutex. If you want minimal locking, so you want again, if we don't want recursive mutex, we want to have something that the top level API that locks it, and then deal whatever you need to deal safely. By the protocol, like you have a protocol that tells you that this is safe to invoke functions, methods in the class without the need to relock the mutex. Solution is pretty simple. All the interface, all the C++ public methods, and we'll see an example in the next slide, these functions should only acquire or release the components, let's say with our AII. So they acquire at the beginning and release it toward the end, or maybe before if needed. So at the border of your API, this is where you have the sync checks of your component in order to achieve thread safety. So once the lock is acquired, all the methods that you invoke inside this class, they're going to be private. I'm not dealing with protected, just private. This function would probably perform the actual business logic, so they'll perform the actual implementation. And once it's done, it's releasing it. Private and protected methods. I'm not dealing with protected. I'm mostly dealing with private and public. The private should only perform all the things that are being called by the interface method. You don't want to call an interface boundary from the internal implementation. Okay, the internal implementation always assume that the lock is being taken care of. It is safe. This is the protocol that you have in this pattern, this thread safe interface pattern. You don't need to require the lock. And then, yeah, as I already mentioned, you never call up the interface, because that you're breaking the promise that the API, the external API is exposed only to the users of this class. You lock and then call the internal ones or the implementation ones. And there is a convention in the book to use _I for mirroring the internal ones. So lookup would have lookup I, insert would have insert I, but it doesn't have to end with insert I or lookup I. Lookup I might call to more functions inside the private section of file cache. All of them are guaranteed to be safe in the sense that it doesn't. Not, first of all, the idea here is that the class is small, simple. There is a single responsibility, so we don't deal with multiple mutex. So you break the multiple mutex into classes that they have they implement their own thread safe interface. And it's never a good idea to have like a big class with lots of members and lots of mutex members inside the class. It's never a good idea. So this would be like how the interface would look like. But if we kind of zoom in, you see that in the lookup we have regarding, like, think about this as a low guard or any other RAII similar to low guard. and then you call lookup I. You can call other, not only lookup I, but anything that is in the private one. Mutable here is because const, usually you have mutable on the log, so you can actually use the mutex in a const function. That's kind of the old trick. Here's an example. Check cache I doesn't have any corresponding interface on the public API, but it's safe to invoke it without calling any, without reacquiring any mutex. This works perfect. Actually, it's being used in many libraries. One of them is ACE, the Adaptive Communication Environment, which Douglas Schmidt, which his name is here, kind of known person in the community. So he's part of the authors. Frank, I don't know if he's still on the committee, but he used to be, at least used to be at the C++ committee. I'm not sure. He's from Germany, if I'm not mistaken. Also a very known person in the community, in C++ community. So variants, thread safe facade, you basically have a class or some system that locks before you access the backend, which is all safe to use without resynchronization and reacquiring a lock. So thread safe facade is one of them. This is a variant of that. So both of them are very similar. And again, ACE, I'm not sure, I've just copied that from the book. I'm not familiar with these frameworks, and Java and security checkpoints are very similar. Again, the public facing is doing all the heavy lifting of the locking, and then you're free to start using the internals. Works perfect. I actually managed to migrate systems into such variant of the interface, the safe thread safe interface, and it worked very nicely. It's increased robustness. I don't need almost all the time that I don't need like a more expensive mutex like recursive one. I don't see any deadlocks. Again, I do need to have like fine-grained types, so I don't have like multiple mutex in the same one. It's harder to deal with anyway, and it can be also used in conjunction with what we saw in the other slides of wrapping the data, associated data with the data structure. I actually doing it in my code to have a better usability to an existing code that is cluttered with mutex and data structures. I mentioned enhanced performance because we don't need to acquire or release any locks unnecessarily. It's pretty much very structured, and it's easier to reason when you read the code because you don't need to deal with if you follow the convention. You need to, like, enforcement wise, there is no tool to enforce it, but there is a convention that you need to build it, and hopefully you have a small class that is easy to reason about. The problem is that you adding another redirection, you add an extra method. They are inlined, so it's not a big deal. It's inline would mitigate that. Still, you still have potential deadlocks. Think about a callback that implements to a class that implementing this thread safe, holding a lock that is not using a recursive mutex. So basically, you enter a class, you hold the log, and there is a callback that ends up with the same one to the same interface, and you basically, so callbacks are always like a pain to debug and develop because they can easily get out of hand and hard to deal with. Misuse, obviously that's a problem, especially this is actually an interesting use case. Same type classes, different instances, you can call the private section. So same type, right? Same type. You bypass the public API. So you bypass the mutex that is part of the class from one type to another type, which is kind of an interesting use case. It comes up every time when we have such similar issues. When you have classes with the same type, instances can access the private access specifier of the other one. Yeah, potential overhead. Each object instance have its own lock. Sometimes you need multiple locks in order to get something done. Think about nested classes that implement such interface. It is what it is. Might increase lock contention, reduce performance, have threads preempted, lots of stuff. Sometimes you see that it's related to decorator. You can always take a class and decorate it with that, like give a facade that locking pattern, strategies locking pattern, that templatizing the lock is what I was referring to. And Java, again, I'm not a Java person. It says that implement locking via monitor object. You have a synchronized keyword where you can use, and monitors are recursive. Okay, so before we end, I want to highlight modern CPP blog post that was actually talking about the same thing. So I have about 3-4 slides, and basically that's about it. So same deal. What happened here? You have a struct with a member function 1 and then member function 2, and you call lock here, and you're not sure. This is so common in so many code bases. I'm not sure, so I'll hold the mutex, and the next thing that happens, this mutex becomes a recursive mutex very, very fast, because deadlocks happened. And okay, why change it to recursive? I change to recursive because I see a deadlock, and that's the only way for me to make a change and go home early, is to make this change. But you pay for it. So that's an issue, right? So the idea is, again, implementing the thread safe interface. It's the same deal that we talked about. You have interface 1 and interface 2. Interface 2 calls 1, 2, and 3 without an issue. It's pretty robust. Again, the class is small, easy to reason about. That you need to strive for that. If you have static mutex, that's basically true for all the instances of the class type critical, which sometimes might be desired. Since C++ 17, I can actually initialize that with inline static. That's an easy way to achieve. So that's a variant of this is basically the generic one. This is a variant that you can still have, which is fine. And then the last one is virtual. So the idea behind virtual is the following. You have this interface in the base class, which lock the mutex. So this is an interface. It's not a pure interface. Base has mutex. And then you have a derived. I specifically have override here, so I make sure that this is an override. But the problem that I have here with this derived is that since it's override, there is a decided. It's like if I go through the base, I just use the base. What I mean is this is fine. But if I have a derived, this is a bug. It says actually here derived without a lock because I'm overriding, right? So you need to be careful when you have virtual interfaces, and you think about this method, because it's not going to work. So the mitigation of having that is related to the non-virtual interface. I don't have a slide on that, but think about the non-virtual interface where the public interface is non-virtual, so you cannot override it. So when you call the function, which is a public interface, it's not virtual, and it's holding a lock, and then you can call a virtual function which is private that you override in the derived, and these functions, the ones that can be overridden and they are private, they are all free from locking. The lock happens from the public API interface. So that's basically a solution for this issue using the NVI, the non-virtual interface. Actually, the non-virtual interface, I really like it because although it's a bit more verbose, but the separation of concern between the public API and the contract that you have with your derived classes, this separation, I really like it. It makes life much easier and kind of easier to reason about with another interaction, yes, but I think it's worth it to kind of maintain the solver. That's all I had for today. Unfortunately, we had Will that was also slated to be here, but we don't have him for today. So thank you for sticking around. Do you have any question?
Thank you.
Thank you.
Thank you.
Yeah.
See you next time with Conan. Next month will be with Conan with Jeff.
Thanks for the presentation.
Thanks everyone. Thanks.
Thank you.
Take care.
Bye.
Bye bye.